Okay. So let's start today's class. اليوم حيكون امتداد اللي درسناه الأسبوع الماضي. زي ما ذكرت نحاول نلخص شوية اللي أخذناه الأسبوع الماضي. الأسبوع الماضي بدينا بأنواع الفلترز. We started with types of filter circuits. Explain that the filter is a circuit that allows specific frequencies to pass through it and blocks other frequencies. We use the radio as an example. When you select a radio station, you're only allowing the specific frequency of that station to pass. Okay? Based on that, we had 4 different types of filters. We have the low pass filter, and the low pass filter would allow low frequencies lower than a specific cutoff value to pass. So these will be pass band, and any frequency above that cutoff frequency will be in the stop band, meaning it will not pass through the filter, it will be blocked. So we call that the low pass filter, where this axis represents frequency, omega, and this axis represents gain, magnitude. And then we had a high pass filter, which was the exact opposite. Frequencies above the cutoff frequency would pass with a gain. Frequencies below it will be blocked. And then we also studied the band pass filter. And band pass, as the name indicates, will allow frequencies within a specific range to pass. Below that range will be 0. Above that range will be 0. And a specific range between 1 and omega C1 and omega C2 will pass. Okay? Last week we studied this concept. We also studied how to build a simple basic filter circuit. And we learned that you can use simply just a resistor and a capacitor connected in series to build a filter. If you take the output across the terminals of the capacitor, so this is your V out and this is your V in, you build the low pass filter. If you take your output at the terminal of the resistor, VR, and your input here V in, you build a high pass filter. If you combine 2 circuits, one of low pass, one of high pass, for example, if I connect here a high pass filter, then I build a band pass filter. Okay? Now, if you look at here, any filter that is built with a resistor, a capacitor, an inductor, or a combination is called a passive filter. Today, last week we studied passive filters. Today we're going to look at a different type of filter, which is the active filter. So what is the main difference between passive and active? And what is the meaning of an active? Let's start with the components. The only difference, or the way we can tell if a filter is active or passive, is by looking at the components that we use to build it, right? So as I mentioned, if you use a resistor, R, a capacitor, C, an inductor, L, and these are the only type of components you use, this is called passive. Why is it passive? Because it only filters out unwanted frequencies, but it does not change the gain. بمعنى, if you want to listen to a radio station using a passive filter, you cannot increase the volume. You cannot hear it louder. You can only listen to that specific frequency. Make sense? In contrast, and we call this passive components, it's called a passive component because it doesn't add gain. It doesn't add amplitude or gain. If I use all 3 of those plus an operational amplifier, which we call op-amp for abbreviation, we build what we call an active filter. Why do we call it active? Because the active filter will add gain. بمعنى, if your input voltage, for example, was 2 volts, your output voltage could be more than 2 based on the gain value. If the gain is 3, the output will be 6. Input of 2 and gain of 3, the output, and so on. So it adds gain. The only purpose of the op-amp is to add gain, and therefore we call it active filter because it actively contributes to the output. It not just filters out unwanted values. It filters out unwanted values and adds or introduces gain to the circuit. Does that make sense? So by just looking at the circuit, you should be able to tell whether it's passive or active by looking for this component. If it's there, it's active. If not, it's passive. Clear? Okay. Let us look at where. Just a moment. Why do we need to have active? So we said we already have the active. So why do we need to introduce gain? This is because sometimes you need to have more than unity gain, more than one. You want the gain to be the input to be larger than the output to be larger than the input in terms of amplitude. An example of that is to enhance or to boost the signal, to have a better quality of signal. You want to enhance the audio. You want to enhance the signal to noise ratio. So you want to give it some gain for clarity. And because sometimes it's easier to use the op amp because it creates a less complicated circuits if you incorporate it. And we'll see that in a moment. But before we go there, before we go to all of that, let's get familiar with the op amp. So I told you that this type of circuit diagram, this is the simple for the operation amplifier. By a show of hands, are you familiar with this? No? Anyone who's familiar with this, just raise your hand if you know what an op amp is or you've seen it before. No. Okay. Are we familiar with the resistor, the capacitor, the inductor? Okay. So these are two terminal devices, right? Two terminal means it has two ends. The op amp is a three terminal device. Are you familiar with the transistor? The op amp is a circuit built with two transistors. Okay? I don't want you to go into depth into the physical structure of it and how it's built and so on, but I want you to think of its circuit equivalence. In terms of a circuit, what does it look like? It looks like this. It's an element or a component that has three terminals or three effective terminals. Two inputs, one output. So this is different than the resistor, capacitor, inductor. All of them are two terminal devices. The op amp is a three terminal device. It has two input points and one output point. The two inputs, we refer to them as the positive and the negative input terminals. One we call positive, one negative. So we have positive and negative input terminals. And then we have here an output, V out. Okay? Now the op amp offers a gain. So if the difference between the input terminals is a value, let's say X volts, and the gain here is A, V out will be A times X. If the input is 2 volts and the gain is 3, the output will be 6 volts. If the input is 4 volts and the gain is 3, the output will be 12. So whatever input you multiply by the gain will give you the output. Clear? And we notice that there is an internal resistance. Internal means inside the body of the op amp that connects the two input terminals, and we call this Rin. And then there is an output resistance connecting the gain point to the final output, which we call R out. Now this is a circuit equivalent. This is not how we realistically build an op amp. We don't bring voltages and connect them like that. But this is the circuit equivalent. However, for simplification purposes, from this point until the end of the module and during the exams, we are going to make an assumption that we're dealing with ideal amplifiers. Okay? Ideal amplifiers will simplify the calculation of any problem that involves an operational amplifier. So what makes an amplifier ideal? An ideal amplifier can have an infinite gain. There is no limitations to the gain. It's up to you and your design, and we'll see how we can calculate gain in a moment. But keep in mind that only in ideal amplifiers we can have any value of gain. Realistically, gain is limited by the operation amplifier itself. Okay? Another thing is, please keep that in mind when you're working on your group project. Because if you use an amplifier, you're going to test it in simulation, which will be ideal, and you'll be testing it in hardware, and hardware is not ideal. So you might expect some non-idealities in the output, okay? The other thing we assume is that this input between the two terminals, between V1 and V2, is extremely high, that there is no connection between them. They are floating, as if this is an open circuit. Rin is infinite. The third assumption is R out is 0. And what does that tell you? If R out is 0, it means there is no drop of AV out, AV in the gain. As is, you can see at the output, and therefore the gain is infinite. So there is no drop internally. The device itself does not consume any energy because we're assuming it's ideal, it's perfect. On its own, it will not consume energy. It will just take whatever input we have and amplify it. Okay? So these are the assumptions. And when we consider these assumptions, we end up with two basic conclusions. That for an ideal op-amp, whatever voltage you apply to one of the input terminals, it will appear at the other. So V positive will always be equal to V negative. There will never be any difference between them. Okay? The other assumption is there is no current entering the op-amp because it has zero consumption, meaning current cannot go through it. Clear? So we assume that no current is entering here. This does not exist. Clear? Okay. So keeping that in mind, I'm going to explain to you first how we can design a gain operational amplifier circuit, and then how we can combine it with a passive filter to create an active filter. So up to this point, do we have a question? Are we clear about ideal operational amplifiers? Okay. What are the conditions that make an amplifier ideal? If you look at this graph. So here I have the values, the realistic assumptions. Ideally, what do we have? We said two main conditions at the end, or two main rules. What about the input? For an ideal, what is the input? Yes? We have infinite gain, that's okay. And the input voltages, what do we know about them when they're ideal? I need you to memorize these two rules. It will help you with simplification. V positive and V negative. What is the relationship between them? There will always be equal. This voltage in this point here and the voltage at this point will always be equal. Which means if I connect this input to a voltage source, let's say of 5 volts, and I connect a voltmeter here, what will be the reading? 5 volts. If I connect it directly to ground, 0 volt, what will be the reading here? So whatever you apply to one terminal will appear at the next. This is the first rule. The second rule is the current from the positive terminal is equal to the current from the negative terminal equal to 0. Meaning it's impossible for current to go into the op-amp. Clear? Okay, let's keep these two rules in mind. They're very important. And now let's think of how we design an op-amp circuit. We have two options. Keep in mind, an op-amp is a circuit that only gives gain. It will only amplify whatever you put at its input. It will be seen with a gain at the output. Okay? There are two ways. The first method we call the inverting amplifier. Do you know the term invert? What does invert means? Exactly. Flip the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. So as the name indicates, the inverting amplifier will actually take your input, amplify it by a factor, and flip its direction. How do we know that? This specific type of connection is called the inverting amplifier circuit. So let's see how does it behave or how does it perform. Now remember, always when you want to know what is the circuit gain is, it's the output divided by the input, right? Generally, this is for any circuit. The gain is output divided by the input. So if you look at this circuit, the output is V out. The input is Vs. So the gain G is V out divided by Vs, correct? Let's try to calculate the gain. So what I have to do is go back to my assumptions of an ideal amplifier, right? So I want you to look at the voltage at the input terminal here. What is it connected to? The positive input voltage. If you look at the circuit diagram. What? Come again, online?
Positive.
It's positive, it's the positive terminal, but what is the value here? How much volts? 0, right? 0 volts. So V positive is equal to 0, correct? Which means that the voltage here at the negative will be how much?
0.
0, correct. So that's the first scenario. The first rule of ideal op-amp, that we have a virtual ground because of the rule of the ideal op-amp, right? The second thing is equals 0 equals V negative, right? The second rule is I positive is equal to I negative equal to what?
0.
0 amperes, which means that the current here is what? 0. So there is no current passing here, as if there's no connection, right? Okay, keeping this in mind now, let us look at this branch. Are we following? So let's redraft it. We start at the first point, which is this point. What is the value of the voltage here? No, this is
0.
Vs. Vs, this the input voltage. Okay? So we have Vs, and then we have a resistor R1. What is the voltage at the second terminal of R1? So we went here and then 0, correct. And then we have R2. And what is the voltage at the second terminal of R2? When we get to here? V out. V out.
0.
Not 0. V out. Here we have V out. From here to here, the voltage difference is V out. Means that voltage is? Make sense? All right. Let me explain to you the concept of how V in is Vs and V out is. Okay. We established that the voltage here is 0 volts, and therefore we have a virtual ground here, right? The voltage difference between this point and this point is Vs, which means that the voltage here is Vs, because here it's 0, right? Between this point and this point is V out. And since this is 0 volts, this means the voltage here is V out. So we end up with this graph. Do we agree with that? Okay. Now let's use Kirchhoff's current law. Do we remember it? It uses the energy conservation law, قانون حفظ الطاقة. The sum of currents entering an electrical node is equal to the currents leaving the node, right? So let's look at here. And do we remember that the current flows from high voltage to low voltage, right? So if you look at the R1 branch, the current will go from here to here. And let's call this I1, the current passing through R1. It will go from Vs to ground, right? Similarly, in R2, the current will go from Vs to ground. And we'll call this, let's call it I2, the current passing through R2. Do you agree with that? Okay. Now let's apply in this node over here, and I'm gonna call it G because it's connected to the, or not G because we already have a G. Let's call it node X because it's connected to 0 volt, right? So the current passing through R1, I1, is entering the node, right? Let's apply Kirchhoff current law. In node X, I1 plus I2 is equal to 0, correct? Both of them are entering the node and no currents are exiting the node. Or in other words, I1 is equal to negative I2, right? Make sense? What is I1 equal to? Using Ohm's law, current is equal to what? Voltage over resistance. So if I want to know the voltage passing through a resistor, it's equal to the difference between the voltage at its terminal divided by the resistance value, right? So if I want to find the current passing through R1, I1, it will be equal to Vs minus 0 over R1, correct? Similarly, if I want to find I2, I2 is equal to what? V out minus 0 by R2. Beautiful. Meaning Vs over R1 is equal to minus V out over R2. Can we cross multiply? So what you'll end up with is V out over Vs is equal to minus R2 by R1. And this gives you the ratio of the output to the input, or in other words, the gain. So the gain depends on the value of R2 and R1, right? And you'll notice it will always be V out over V in is equal to negative R2 over R1. So what does that mean? It means if your input is a positive signal, plot it here. If your input is positive, your output would be negative with a gain. For example, if your input is 1 volt and your gain is 2, your output will be how many volts?
-1.
With a gain. Make sense? Okay, so now if I ask you design a circuit with a gain of 5, how would you do that? You already have the circuit diagram. This is the circuit that gives a gain. Even though it flips the sign of the signal, but it gives it with a gain, right? So if you want the gain to be 5, you'll say that R2 over, this side does not plot. You'll just say that the ratio R2 over R1 is equal to 5, which means R2 has to be equal to 5 times R1, right? You can choose 1 and 5, you can choose 5 and 25, you can choose 100 and 500, any two values for the resistance that will give you a ratio of 5 can be used to design a circuit with a gain of 5. Clear? Make sense? So this is what we call the inverting amplifier. The second way that we can build an amplifier circuit is the non-inverting. But before we go there, I just want you to pay attention to one thing and then we'll move. If you look at this inverting amplifier, where is the external input connected? To the negative or to the positive terminal of the amplifier? The external input, V source. Where is the source connected? Then it's connected to R1, but connected to negative or to positive? Negative, right? Through R1, but to the negative, right? Yes. So when the connection is to the negative, we call this an inverting amplifier. The second option is non-inverting, and you'll notice in the non-inverting, the source is connected to the positive. But one thing is fixed. The location of R2 and R1 remains the same. You notice? R2 and R1 are not changed. What changes is in the non-inverting, the input is connected to the positive terminal and the negative is connected to the ground through R1. So we have one connection to the ground, one connection to VS. When we were using the inverting, the positive was grounded, the negative was connected to the input. Make sense? Okay, so now if you look at this circuit, again, the circuit will give you a gain, but it's called non-inverting. And the reason why it's called non-inverting because the gain doesn't change the direction of the input. If the input is positive, it will be positive. The output will be positive. If the input is negative, the output will also be negative. It does not invert the direction of flow. So let us try and evaluate the gain of this circuit. We said the gain is equal to what? The gain of any circuit is equal? V out by V in for any circuit, whether it's an amplifier or any other type, the gain will always be the output divided by the input, right? Now to define this, we have to use the same steps we used earlier. We have to assume that it's an ideal amplifier, and then we try to find a relationship or a ratio of V out over V in. So when we start with our ideal assumption, V positive is equal to V negative equal to what? 0. Are we sure it's a 0? What is the voltage here at this point? Vs, right? Which means that we are forcing, it depends on which value you are forcing. And if you connect it to 0, it's a 0. If you connect it to something else, it will take whatever value you connect it to. So the value here is Vs, which means the value here is what? Vs also. So V positive is equal to V negative equal to Vs, right? And the second assumption is that the currents at the positive and negative terminal are equal to?
0.
0, perfect. And then I will repeat the exact same process and I will take this feedback line all the way to the ground. Okay, now let's plot it. We are starting with V out. Then I have what? R2. And then I have a point here where the voltage is equal to Vs, right? And then we have R1, and then we have ground, right? Are we following? Make sense? And then I will try to evaluate current. We said that the current goes from high voltage to low voltage, right? So the direction of current will be from V out to Vs, from Vs to 0, right? Let's call this I2, and let's call this I1. And let's now apply Kirchhoff current law. What would be the application of Kirchhoff current law in the node of Vs? So what would be? One entering, one exiting, right? It says the sum of currents entering is equal to the currents exiting. So the formula will be what? I1 is equal to I2, right? The current entering is I2. So I2 here is equal to I1 because I2 enters and then it will exit as I1, correct? And then let's use Ohm's law to find what is I2 equal to and what is I1 equal to. So what is the current I1? The current passing through the resistor R1. Using Ohm's law. V what?
V out.
Which one are you getting, I2 or I1? I2. I2 is equal to V out.
By R.
V out by R2. The voltage between the resistance R2 is what? We don't get just one terminal. You take the two terminals. The voltage difference فرق الجهد بين طرفي المقاومة صح؟ إذن V out minus what? VS يعني this is V out, this is VS. V out minus VS divided by R2. This is I2 equal to I1. What is I1? The same process. فرق الجهد بين طرفي المقاومة على قيمة المقاومة which will be VS
by V.
What is the voltage here? What does this triangle means? 0. VS minus 0 divided by R1.
R1.
Clear? Okay, let's continue. Yes, this السهم واللي مكتوب عليه VS دي معناها انه فرق الجهد بين النقطة دي والجراوند VS. فده معناها انه الفولتج في النقطة دي عبارة عن VS ناقص صفر بتساوي VS. اوكي؟ وبنفس الطريقة الفولتج في النقطة دي هي V out. طيب إذن let's rewrite it here. VS minus 0 over R1 is equal to VS over R1 equals to V out over R2 minus VS over R2, right? طيب. Remember, we want to get to the answer to this ratio. So what I will do is, let's move this here so we can keep VS in one side. So we'll end up with VS over R1 plus VS over is equal to R2, perfect. Then I'll take VS as a common factor. So what do I end up with? VS multiplied by 1 over R1 plus 1 over R2, right? Equals to V out over R2, correct? Now from this stage, from this step, can I find V out over VS? How do I find V out over VS? Cross multiplication, right? أقسم على القوس ده 1 على R1 زائد 1 على R2 وأضرب في R2 صح؟ Cross multiplication. So what you'll end up with, V out over VS is equal to R2 multiplied by 1 over R1 plus 1 over R2. Does that make sense? Okay. Let's now take this R2 and expand. So this is equal to okay, just a moment. Equal to R2 over R1 plus R2 over R2, which is equal to So this is what we have. Make sense? So the gain or the transfer function is R2 over R1 plus 1. طيب, if I want to have a gain of 5, what will the value of R2 and R1 be equal to? If you want to design a non-inverting amplifier with a gain of 5, بمعنى if the input is 2, the output should be 10. If the input is 5, the output should be 25. So the output should be 5 times the input. How would you decide the values of R2 and R1? Okay. We said that the gain is equal to R2 over R1 plus 1, right? If you want the gain to be equal to 5, then the ratio R2 divided by R1 should be equal to what? 5 minus 1, which is 4. And this one will go there. So you choose any two values where R2 over R1 is equal to 4, or in other words, R2 is equal to 4 times R1. And if R1 is 2, R2 has to be what? 8. If R1 is 5, R2 has to be 20. And you have to select one value and make sure that the other value is 4 times that value. Does that make sense? Clear? Okay. Questions? Are we all good? What it will do in the circuit? It will just add gain. يعني إذا الانبوت إذا الفي اس كانت كل هدف منه الامبليفاير دائرة كدائرة الهدف لا ما عندها علاقة بفيور. يعني قصدك إنه lower input بحيث إنه أقل منه حيشتغل الامبليفاير؟ No, we're assuming ideal. يعني if you put 0.1 volts and the gain is 4, the output will be 0.4. فهمت؟ يعني بيضرب القيمة بس بيضاعفها. عدد الأضعاف كم معتمد على الجين. Is it clear? طيب. We said إنه the whole purpose of this amplifier, now we learn two ways to build an amplifier. Both will amplify the output, but one will amplify and invert, and one will amplify without inverting. طيب, the whole purpose of the amplifier, we said, and when we design a filter, we want it to be active, which means we want to add gain. And the amplifier purpose is to add that gain. So how do we design a filter with an amplifier? طيب, I know that some of you didn't attend last week, so it will be difficult for them to pick up the filter. But just to help you pass along, let's remember that last week we learned how to build basic filters with resistors and capacitors only. This circuit with a resistor and the capacitor builds a low pass filter where this is the output and this is the input. Okay? If you take the exact same circuit but just replace the output terminals and say that the output is the voltage across the resistor, this will build a high pass filter. If you want to build a band pass, you'll take high pass and low pass and connect them in series. Okay? This is just a quick recap of what we did without further details because we don't have time for the details, but okay, just to help you pass through. So if I want, and these are passive, ما فيهم up amp. These are passive filters. All they do is filter the value of the input based on frequency. They don't add gain. So if I want to create an active filter, one of the simplest way to do it is take this passive low pass filter, for example, and connect it in series with this amplifier circuit. Simply just take an amplifier, connect it to the output of the filter. This makes an active filter. Now, before we move on, what type of amplifier do we have here? Is it an inverting or non-inverting? Where is the input of the amplifier connected to? Non-inverting. Because it's connected in the positive, the positive input. So this is a non-inverting amplifier. The gain for a non-inverting amplifier is 1 plus R2 over R1. And the gain of a low-pass filter, we studied this last week, go back for it to check, is 1 over 1 plus RCS. So the total gain of the circuit, V2 over V1, will be the gain of the first part multiplied by the gain of the second part. which is this equation over here. So you'll notice this is the filter, and this is pure gain. Ideally, the op-amp doesn't do any filtration. It just enhances the output value. Clear? Now, let's look at the circuit on the left. If you compare it to the circuit on the right, R2 is equal to what? And remember, R2 will always be the resistance connecting the output to the negative input terminal. What is the resistance between the output and the negative input terminal in this line, feedback line? 0. There is no resistance. When there is no resistance, that means the resistance value is 0, right? The current is passing. So if R2 is 0, and what is the value of R1? R1 is the connection or the resistance connecting the negative input terminal to an external input value. What is the value of R1 here? Not 1. Is there any R1 here? There is no R1, right? I'm looking here at the left side figure. Is there any R1? Which means that R1 is equal to, when the resistance is extremely high, it's infinite. We say it's an open circuit, right? As if there is no wire. So here we don't have the wire, which means that R1 is equal to. So if I want to get the gain of this non-inverting amplifier, it's 1 plus 0 over infinity, right? And 0 over infinity is what? 0, right? So the gain is equal to 1. This is called a voltage follower. Whatever is at the input, the gain is 1. Input is 2, the output is 2. The input is 3, the output is 3. The gain is 1. We only multiply by 1. We call this type of circuit the voltage follower. Is it clear? And sometimes we need that voltage follower to act as a buffer. Remember when we had the second order filters and we had a buffer? It would be a voltage if you don't want to enhance the gain. You just need to create a buffer. This could behave as a buffer that doesn't introduce gain. Are we clear so far? So this is how we build a low pass filter. Now we've already been through this process. So if you compare the gain, this is the gain without amplification. You'll notice it looks like a passive gain. And with amplification, this line, you'll notice now it has an amplitude. So if you plot them line by line, you'll see that this is without amplification. It will go like this. It will be a slightly lower gain. With amplification, it will be a higher gain. The cutoff frequency will remain the same. So the amplifier ideally doesn't change the cutoff frequency. The passive components are the part that do the filtration. The op-amp only enhances or boosts the voltage value. Are we clear so far? So if you look here, how many components did we use in this circuit to build a low-pass active filter? How many resistors do we have?
3.
And how many capacitors?
1 more.
So we have 3 resistors, 1 capacitor, and an op-amp to build a filter, right? I can achieve the exact same output, the exact same transfer function, and the exact same frequency response with this design. If you look at this design, how many resistors do we have? 2 resistors, 1 capacitor, and op-amp, right? So with lesser number of components. Now, keep in mind that right now I'm just looking at a simple basic circuits, but when you scale it up, it becomes more complicated. The reduction will be even more significant. But if you look here, I used a lesser number of components, but it will be the exact same output. And the reason is I implemented the filter in the feedback loop. We call the line connecting the output to the input the feedback loop. So what I have done is I've changed, instead of having filter in series with an operation amplifier circuit, I've put the filter inside the circuit as part of the operation amplifier itself. So what happens is, if you look at this circuit, what type of amplifier do we have? Inverting or non-inverting? Non-inverting. Are we sure?
Yes.
Let's go back. Just give me a minute. We'll copy it and then we will discuss this one more time. Okay, let's look at this circuit. Is it inverting or non-inverting? Inverting. Do you all agree? Who agrees it's an inverting circuit? Who says it's a non-inverting circuit? Okay, the 6 who abstained. Who is struggling to understand? شوفوا الفلتر عليها سؤال في الاختبار عليه 25 درجة. اوكي؟ واحد من الأسئلة حيكون عشان نشوف الامتحان مكشوف يعني ما تتعبوا فيه. What type of filter does this circuit implement and justify your answer؟ هيجيكم سؤال فيه دائرة مرسومة. حدد نوع الفلتر وبرر قرارك. بالطرق أو الخطوات اللي احنا بنتعلمها اليوم حتستفيدوا منها في الاختبار. دي خطوة. الشيء الثاني انه الديزاين للكورس ورك معتمد على الفلترز. فإذا سألته هنا أحسن مما تسأل في الاختبار صح؟ هل عندكم مشكلة في ما فاهمين كيف نحدد الفلتر إذا inverting أو non inverting؟
موصل في الماينس لا؟
إذا موصل في الماينس يعني زي ما ذكرت yes correct. إذا الانبوت موصل في النيجاتيف معناها inverting. إذا موصل في البوزيتيف non inverting is very simple. أوكي؟ دي الخطوة الأولى. الخطوة الثانية now we want to test what type of filter or what type of behavior the circuit will have. طيب قلنا this is inverting والجين للinverting كم حسبناه قبل شوية؟ الجين بيساوي إيه؟ Let's go back to the inverting circuit.
P out by PS.
دي الانفيرتنج. الانفيرتنج قلنا الجين بيساوي نيجاتيف R2 على R1 صح؟ طيب دي للمثال ده للدائرة دي تحديدا. لكن في المطلق الانفيرتنج عبارة عن المقاومة الكلية في الفيدباك لاين. يعني whatever الحاجة الموصلة بين الاوتبوت والنيجاتيف انبوت we call this feedback line على المقاومة الكلية للانبوت لاين. حلو؟ يعني R2 تمثل whatever is in the feedback line و R1 تمثل whatever is in the input line. فلو فتحنا هنا الفيدباك لاين عبارة عن R2 in parallel with C right؟ والinput line عبارة عن R1. فالgain is negative Z2 over R1 حيث Z2 sorry is equal to R2 in parallel with ZC. clear؟ ماشي الحال إلى الآن؟ ولا شوية تعقدت؟ نعيد. احنا القانون المطلق يعني احنا في البداية في الرسمة الأولى قلنا R2 على R1 صح؟ لكن الصيغة العامة من القانون إنه الgain of an inverting amplifier is equal to Z feedback over Zn. دي القاعدة العامة with a negative sign. Z feedback هو مجموع المقاومة الكلية أو المانعة الكلية في الخط الواصل بين النقطة دي والنقطة دي feedback line. تمام؟ وزد ان هي المقاومة الكلية بين الاكسترنال انبوت والنيجاتيف انبوت تيرمينال. حلو؟ ففي مثالنا الحالي الزد فيدباك عبارة عن R2 parallel C عبارة عن مقاومات موصلة على التوالي صح؟ والانبوت تيرمينال is R1. اوكي؟ طيب إذا أنا عايزة أحسب قيمة الجين الكلي أو V out. الجين هو عبارة عن V2 over V1 or V out over Vin صح؟ فلازم أعرف what is the feedback and what is the input and then divide them by each other to get the value, right? طيب the back line, the feedback line is Z2 و Z2 عبارة عن مقاومة موصلة على التوازي مع مكثف صح؟ طيب حافظين قانون التوازي؟ total impedance for a parallel is what? صح؟ which means that Z2 اختصار كان إنه ضربهم قسمة جمعهم. Do you remember this? Yes? و ZC is equal to what? ZC بتساوي 1 over SC صح؟ ZC is equal to 1 over SC. إذن Z2 is equal to R2 multiplied by 1 over SC divided by R2 plus 1 over SC. اللي هنا أوكي؟ طيب let's simplify it لأنه remember we want to substitute it هنا في الجين. let's simplify it. نبدأ بالمقام. هنبسط المقام كيف؟ we will unify the denominators in the denominator. هنوحد المقامات للمقام. So R2 times 1 over SC remains the same. R2 divided by SC. All divided by المقام المشترك الجديد حيكون كم؟ What will be the new؟ المقام هنا كم حيكون؟ الSC دي صح؟ هنوحد مقامات المقام. R2 زائد 1 على SC المقام المشترك حيكون SC. But this one will be okay all divided by SC. First term حيكون R2 مضروبة في SC. So SC R2 plus 1. Okay؟ ماشي الخطوة دي؟ Okay؟ Yeah? Okay. SC will SC cancel each other out. What do we have left? R2 over SC. R2 plus 1. This is Z2, right? Let's call this 1. Substitute 1 in star. What do we end up with? Gain is equal to Z2 اللي هي R2 over SC R2 plus 1 all divided by R1 with negative sign, right? Which means that the gain is equal to negative R2 over R1 all divided by SC R2 plus 1. صح? This is a multiplication sign. This here is a gain of a regular standard inverting amplifier. This here is the standard transfer function of a low-pass filter. So we created the exact same transfer function, but with less number of components. We reduce the number of resistors we have used. Does that make sense to you? So this is one way to build it. Meaning, the whole purpose of this is to show you that to build a filter, there is multiple ways to do. There are innovative ways that will give you the exact same output with less number of components, even though it's not as straightforward or as easy to design. So when you're working on your group project and you're designing, try to look up these types of designs, the innovative designs. This is simple design. Try to look at more innovative designs so that you can achieve the requirement with minimum consumption of energy, of space, of footprint, and of components. Clear? Any questions up till this point? طيب كده اتعلمنا كيف نعمل لو باس فلتر بطريقتين. الطريقة الأولى قلنا إنه ناخد لو باس فلتر وأبقى نوصله مع التوالي مباشرة. effortless calculations. الطريقة الثانية إنه نوصل الفلتر كجزء من دائرة الأوب أمب مثلا في الفيدباك راوت. طيب how do you suggest we design a high pass active filter? Same, exactly same. So what would that mean? A high pass circuit with the op amp in series. This is one way to do it. So what you'll have is this is a high pass filter circuit, capacitor and resistor. And this is what type of op amp? Inverting or non-inverting? Non-inverting, perfect. So this is the gain of the inverting, and this is the gain of the high-pass filter. To know how this equation, the gain for high-pass filter, just go back to last lecture. It will be there in detail. And this one, what is the gain of this one? It is non-inverting, بس الgain كم قيمته؟ 1. نفس الفكرة voltage follower where R2 is 0 and R1 is infinity. Clear? طيب there are another way to build the non-inverting amplifier, the high pass active filter, which is, just a moment, similarly to what we did earlier. يعني في الطريقة الأولى نوصلهم كبلوكس كبيلدينج بلوكس، ناخدهم كبلوكس نوصلها مع بعض على التوالي، والجزء الثاني إنه ناخد الفلتر ونستعمل الفلتر كجزء من دائرة الامبليفاير instead of دائرة منفصلة موصلة معه. Here we have an example of that. Do you notice the difference between this one and this is a high pass filter. The only difference is that the component here is a capacitor. instead of a resistor, right? And this simple change will change the filter from low pass to high pass active filter. So let's calculate the output is V2, the input is V1. Now let me ask you the exact same exam question. What type of filter does this circuit implement, and justify your answer? So what would be the first step? Come again?
High pass.
I told you it's high pass. Let's go to the justify your answer. Find the gain, exactly. Gain is equal to V2 over V1. طيب احنا we said what type of filter do we have here? Inverting or non-inverting? Sorry, what type of op-amp circuit? Are we sure? Non-inverting. Non-inverting the gain is what? 1 plus Z2 over Z1. من وين جبنا Z2 over Z1؟ احنا هناخد التعميم. القاعدة العامة انه for a non-inverting amplifier this is the standard, but instead of R2 Z2 whatever the resistance in the feedback line divided by whatever the resistance in the input line. كتير؟ نفس الكونسبت يعني. طيب let's go back to it. Z2 is this resistance or this impedance, and this is Z1. Okay, let's call this equation 1. What is the value of Z2? Z2 عبارة عن ايه؟ resistor capacitor C2 موصلين على التوالي، صح؟ على التوازي سوري. احنا حسبناها في المثال السابق، فبس حفاظا على الزمن we calculated it to be equal to this، صح؟ R over SCR plus 1, right? It's the exact same. A resistor and a capacitor connected in parallel. R over SCR plus 1. C2. Correct? واضحة إلى هنا؟ Let's call this equation 2. And Z1 is equal to what? ZC1, right? الانبوت هي نفس ZC1 is 1 over SC1. Make sense? Okay. Let's call this equation 3. Let us now substitute 3 and 2 in 1. So the gain, which is V2 over V1, is equal to 1 plus Z2, which is R over SC2 R plus 1, divided by ZC, which is 1 over SC1. Okay, let's simplify it. It becomes 1 plus R divided by SC2, all divided by SC1 is equal to SC1 R divided by SC2 R plus 1, right? طيب, it's still two terms, 1 and a fraction, right? So now let's combine it into a single term. What will be the common denominator? Will be this value, right? SC2 R plus 1. Let's multiply it by 1. SC2 R plus 1 plus SC1 R. Correct? Yeah? Go ahead. Look for it. Okay? Which is equal to what? S times C2R plus C1R plus 1 divided by SC2R plus 1. Do you agree with that? Make sense? Right. Now I'm going to ask you, we reached to the point of gain. Are we sure that this is a high-pass filter? Is this enough to tell us that this is a high-pass filter?
Why would you add SC2?
This one؟ لأنه وحدنا يعني كان عندنا واحد زائد كسر، صح؟ فوحدنا المقامات عشان عندنا كسر واحد، فضربنا الواحد في المقام الجديد. Okay? This is sufficient to say that this is a high-pass filter? No, we have to plot the frequency response. بمعنى frequency versus gain, right? To do this, so we have to first decide zeros and poles and constants. Do you remember this? Yeah. طيب zeros قيم s اللي هتخلي البسط صفر. poles قيم s اللي هتخلي المقام صفر. نحسب قيم الزيروز وقيم البولز لانها بتساعدنا في الرسم اللي هو البود بلوت. البود بلوت درسناه في lecture number 5. Go back for that lecture, but for now let's just go through the process. طيب what are zeros؟ ما هي قيم s اللي هتخلي البسط صفر؟ إذا s بتساوي كم؟ إذا s صفر البسط هيكون واحد.
minus 1.
لا، هناخد إنه الاس ضرب C2 R plus C1 R plus 1 equals 0, which means that S is equal to 1 divided by C2R plus C1R with a negative sign. Okay? دائما يعني the most reliable way to find the value of 0 انك تاخد البسط تساويه بصفر وتحل S. Okay? And do we have so 0 at negative 1 over C2R plus C1R. طيب do we have poles؟ poles هي قيم S اللي هتخلي المقام صفر. What are the pole values؟
We don't have.
Are you sure؟
SC.
Let's try it. SC2R plus 1 equals 0. صح؟ Take the one there. SC2R equals negative 1. If S is equal to negative 1 over C2R, it will be 0, right? Okay, then we have a pole at 1 over C2R, right? طيب أي القيم أعلى 1 over C2R ولا 1 over C2 plus C1R؟ by comparison 1 over C2R ولا 1 over C1R plus C2R. Which one is larger? Which one?
T1R plus
This one is larger. المقام لما يكون أكبر الكسر كلي بيبقى قيمته أقل، يعني 1 على 4 أكبر من 1 على 5 صح؟ فإذا 1 over C2R is larger than 1 over C2 plus C1R صح؟ طيب so let's assume that 1 over C2R is here and the other one will be somewhere less than it. Here 1 over C2R plus C1R, right? Okay? The way we plot a 0 is that prior to the 0, the gain is 0. At the 0, the gain will start increasing. We studied this in the last couple of weeks, so please go back to these lectures. In the exam, I will give you a board plot question. Okay? With the pole, we decrease. When we start to calculate the overall response, what will happen? From the beginning until this point, there is no gain. And then we will increase. And then we reach to this point. One line is increasing, one line is decreasing, so the total rate of change becomes. يعني إذا عندنا السيستم فيه كذا معامل، فيه poles وفيه zeros. طيب؟ فالقاعدة إنه الخطوة الأولى بنحدد أنواع قيم البول وقيم الزيروز. الخطوة الثانية بنرسم كل معامل على حدة، فبنرسم البول منفصلا والزيرو منفصل. نتذكر إنه البول هي قيم أس اللي حتخلي المقام صفر، فإذا لما نوصل للبول يبدأ نقصان في الجين which is the green line. You start straight and then drop. الزيرو هي قيم الاس اللي حتخلي البسط صفر، فلما نوصل للزيرو we start to increase. طيب ال overall system performance is basically the gain of the zero plus the gain of the pole. فمن البداية إلى النقطة الأولى ما في gain, it's zero. The line is flat. And then from 1 over C2R plus C1R until 1 over C2R, the only line contributing to the gain is the blue line. So we follow it. When you reach to this point here, the point of the pole, you have a regular steady increase and a regular steady decrease. So the total rate of changes 0, which means flat, no changes, right? طيب, if you look at this black transfer function, or if this is frequency and this is gain, what type of filter does this implement? High pass filter. So this circuit implements a high pass filter. So when I ask you the exam question of what type of circuit this filter this circuit implements, you have to do all of this calculation and then this plot and then say this circuit implements an active first order high pass filter. There are 3 points to the answer. It's active or passive. What type of order does it implement, which is what is the highest power of S in the equation? And is it high pass, low pass, band pass, or band stop? Clear? Following all of these calculations. Clear? واضح? Any questions so far? So we did this. We did the calculation. We confirmed. Now, let's stop here. Last week, we also studied band pass filter. And we said that to build a band pass filter, all you have to do is connect one high pass filter and one low pass filter in series, so that the overlap between, if this is the high pass and this is the low pass, the overlap between them will be your pass band. But if I want to build an active band pass filter, what would I do? All you have to do simply is add in the middle here an op-amp gain. So it becomes high pass, gain, low pass. So the combination will be something like this. This is the high pass filter. This is the op-amp active component. And then this is the low pass filter. The total gain will be the gain of the op-amp times the gain of the high pass times the gain of the low pass. Clear? So this is how you build a band pass active filter. And it will look like this. It will be the exact same frequency response of a band pass. The only difference is that the maximum gain value, instead of 1 or 0 decibels, will be 20 log the gain of the op-amp. Because if you look here, the transfer function has, well, let's go with the S1. It has a constant, it has a 0, it has 2 poles. Make sense? So up till this point, do I have a question? I know I explained a lot of things, especially for those of you who haven't attended last 2 lectures, because they build on them. But I hope that you at least got the general idea, and I hope that you'll go now and study these 2. Because there will be an exam question asking you to plot both plots. There will be an exam question asking you what type of filter does the circuit implement. Are we clear? At least let's understand the general concept. Yes?
بالفاينل نفس هذا الكلاس ولا نفس الأسبوع الماضي؟ سؤال.
Come again?
Final exam نفس today class or last week?
It's a combination. And if you didn't study last week, you'll not be able to understand this week's. And it will not be the exact same circuit from the lecture. It will be a different circuit. So you need to understand the process, okay?
بس طريقة السؤال نفس أي
نفس طريقة السؤال. السؤال طريقته نفسها. فإذا تعلمتوا طريقة الإجابة بغض النظر عن تغير الدائرة هتقدروا تحلوه. أوكي؟
تمام.
يعني الخطوة الأولى إنه نحدد الترانسفير فانكشن. الخطوة الثانية نرسم البود بلوت للجين. ده هيوضح لكم. خلاص بعد كده تحددوا 3 أشياء مهمة. نوع الفلتر إذا باسيف أو أكتف. درجة الفلتر الأوردر دي معتمدة على الباور اوف اس. what type of filter? Low pass, high pass, band pass, or band stop? Okay. Okay, so online, do I have a question? For those who are in class, I'm going to ask you to first please give me your ID, attendance, write your names, and then move to BG7 for practical session. Those who came in late, please just take a minute to fill in the flash survey and then move on to BG7. Those who are online, please join online in 5 minutes. There will be also an online session for the software part of the lab. The lab will introduce you to software and to the lab components, equipments. The software you can attend online, but for the lab equipment, only those who are in class can practice. So please just take a minute and then move on to BG7. Mr. Basim will meet you there. He'll be your lab demonstrator for today. You brought your IDs?
We will continue there.
you will continue there in BG7. But just wait to write your ID for attendance. Okay.
And this you said zero.
Same link, Doctor, same link.
Same link, yes, just in 5 minutes. Give me 5 minutes to add, to move, because now we're in the lecture room and we're moving to the lab.
Mrs. Hannes.
أمر.
قلت الزيروز اللي نحط البسط صفر.
أيوه.
قلت المقام.
مقام صفر. أيوه صح. يلا. Okay, online, do we have any questions?
No, Doctor.
Okay, I'll exit now, but please remain. After 5 minutes, Mr. Basim will join you.